Hello friends, today we discuss about refraction at a spherical surface. Friends, this is the very important question, right? So the question is, obtain the relative between or relation between object distance and image distance in terms of refractive index of medium and radius of curvature for spherically curved surface. Or the question is also asked like this: prove minus n1 by u plus n2 by v is equals to n2 minus n1 upon r. Right, friends, this question will be asked in 2 or 3 marks. Right, now we have to prove relation between object distance, image distance in terms of the refractive index, but we have to prove this relation for a spherical surface. Right, okay. So friends, we already know about spherical surface, right? The spherical surface is like this, right? Okay, now friends, this is our principal axis, right? Okay, this is the center of a spherical surface, right? Okay, now suppose here at this point we put an object O, right? So we can say that the distance between the center of spherical surface and object is known as object distance, right? Okay, now the ray of light from this object is like this, right? This ray is incident on a spherical surface at point, we assume this is point N, right? Okay, now if we draw a normal from the spherical surface to the principal axis, so this normal is like this, so this point is M, right? So the distance between M and center of the spherical surface is very less, so this is a negligible distance, right? So here I take this point M dash, so here the distance between M and M dash is very less, so we can say that OM dash is equals to OM, right? Because the distance between M and M dash is very less. Okay, now we already discussed that if we draw a normal, so this normal is always passing from the center of curvature, right? We already discussed that. So here this is the spherical surface, right? Like this, this is our surface. So if we draw a normal, then this normal is always passing from the center of curvature C. So the distance between M and C is known as radius of curvature, right? So we can say that MC or M dash C is R, right? Okay, now this is our first medium N1 and this is our second medium N2, but here N2 is greater than N1, so refractive index of this medium N2 is greater than this N1, so here N2 is greater than N1. So here the ray of light is from rarer medium to denser medium, and we know that if the ray went from rarer to denser, then it bends towards the normal. So the ray refract like this. So this is our refracted ray, right? Okay. So here this is the incident ray and normal. So this is angle of incident I, and this is refracted ray and normal. So this angle is angle of refraction R, right? Okay. Now here we also take a second ray of light like this. The ray from object O is incident at point M dash like this. So this ray is passed like this in a straight line, right? So here at this point, this and these two rays are meet. So here we get an image of object O, right? So here the distance between M or M dash to I is image distance V, right? Okay, once again I explain this figure. This is spherical surface, object O. The ray from object O is incident at point N. Here this ray is went from rarer to denser. So this ray is bent towards the normal, right? And we take another ray from object O is incident at point M. So this ray is passed like this. So these two rays meet at point this. So here this is an image of object O. Here this is incident ray and normal. So this angle is angle of incident. Refracted ray and normal. So this is angle of refraction, right? Okay. So we can say that figure shows the geometry of formation of image I of an object O on the principal axis of a spherical surface with center of curvature C and radius of curvature R, right? So friends, we can write this thing. So here we can write like this: figure shows the geometry of formation of image I of an object O on the principal axis of spherical surface with center of curvature C and radius of curvature R. We can write that the rays are incident from medium of refractive index N1 to medium of refractive index N2, right? From N1 to N2, and here N2 is greater than N1. Then you can see from the figure that here OM dash is equals to OM is equals to U, but here as per the rules we have to measure distance from the pole, right? So here we have to measure a distance from the pole, right? And in the direction of incident ray. So here opposite direction. So U is negative. M dash C or MC, radius of curvature. Here this measurement is in the direction of incident ray. So R is positive. Then M dash I or MI, image distance. This is also in the direction of incident ray. Then we have to take V is positive, right? Okay. So this is our sign convention. Now friends, we have to prove relation between object distance, image distance in terms of refractive index, right? So here there are two refractive index, right? N1 and N2. So here see at this point N, this point you can easily see this point N. So friends, we apply Snell's law at this point. So here there are two medium N1 and N2 having refractive index, right? Theta 1 is I and theta 2 is R. So we know this Snell's law, N1 sin theta 1 is equals to N2 sin theta 2. So theta 1 is I and theta 2 r, right? So we can write that from the figure at the point n, by Snell's law, n1 sine theta 1 is I is equals to n2 sine theta 2 is r. But we know that, friends, here the angle is very less, and we already studied that if the angle is very less, then sine theta is equals to tan theta is equals to theta, right? So here we take sine I is equals to I and sine r is equals to r, right? So we can write that for small angles, sine theta is equals to tan theta is equals to theta. So sin I is equals to I and sin R is equals to R, right? So we can write that n1 instead of sin I and n2 sin R. So n1 I is equals to n2 R, right? So we write like this. So n1I is equals to n2R, and this is our equation number 1. We have to prove relation between object and image distance with refractive index, right? So we have to find out value of I and value of R, right? So to find out the value of I and R, we have to consider this figure, okay? So see this figure, friends. Now here see angle I and see this triangle O and C, this triangle O and C. So we can say that I is the exterior angle of triangle O and C, right? So we can write that I is equals to angle NOM plus angle NCM, right? We already discussed about these exterior angles, right? Once again I repeat, from the figure you can see that I is the exterior angle of triangle O and C, this. So we can say that I is equals to angle NOM plus angle NCM, right? So we can write that here I is the exterior angle of triangle O and C. So we can write that angle I or I is equals to, you can see here, angle NOM plus angle NCM, right? Angle NCM, right? Okay, so we have to write angle NOM and NCM. So NOM, see here friends, NOM. So we have to find out this angle NOM, right? So we have to prove relation between object distance, image distance with refractive index. So here you can say that here this theta is tan theta because angle is very less. So we know the formula, tan theta is equals to opposite side by adjacent side, right? Here opposite side is NM or MN and adjacent side is OM. So we can write that angle NOM is equals to Mn upon Om, right? So we can write that I is equals to angle NOM. So opposite side Mn and adjacent OM. So write Mn upon OM plus NCM. See here, NCM. NCM. This NCM. So this angle. So for NCM, tan theta, opposite by adjacent. So here for NCM, opposite is Mn and adjacent is MC or CM, right? So we can write that NCM is equals to Mn upon MC, right? So we know the value. I is equals to Mn upon Om. See here, Om is equals to minus U. So here Om minus U plus Mn upon MC. We know the value of MC. MC is equals to R. So here R. So this is our equation number 2. So we find value of I. Now we have to find out the value of R, right? So see this figure again. See here angle R. So this angle is angle CNI, or you can say INC, right? So whatever you see, you can write angle CNI or INC. Now here the angle R is C, angle CNI. So see this triangle NCI, this triangle. So for this triangle NCI, for this triangle, we can say that this is angle NCM is the exterior angle, right? Because outside. So here angle NCM is exterior angle for triangle CNI, right? So we can write that here angle NCM is exterior angle of triangle NCI, right? So we can write that angle NCM is equals to which two angles? So angle CNI, right? Angle CNI plus angle NIC, this, right? So angle NIC, right? Okay, see, angle NIC, this angle is equals to angle NIM, right? See, NIC, this angle, and for NIM, this angle, right? So we can say that here angle NIC is equals to angle NIM. So we can write that angle NCM is equals to angle CNI plus angle NIM, right? Now angle NCM, see, angle NCM. So once again, the angle is very less than tan theta. So opposite side is Mn, adjacent side is MC. So we can write that Mn upon MC is equals to angle CNI. You can see CNI. So this angle is R plus angle NIM, this angle NIM I m. So once again, mn opposite side and adjacent side is mi. So mn upon mi. So we have to put the values. So mn as it is. Value of mc. See here, value of mc is r is equals to r plus mn upon mi. Value of mi is v, right? So v. Now friends, we have to find out value of I and r. We have already find out value of I. Now we have to find out value of r. So we formulate r. So we can write that r is equals to mn upon r. This is go to left hand side. So minus mn upon v. Right. So this is our equation number 3. Now see here equation number 1. N1I is equals to N2R. We already know the value of I and value of R. So we put the value of I and R in our equation number 1. So we have to put value of equation number 2 and equation number 3 to equation number 1. So we can write that. So from equation 1, 2 and 3 we get N1 I, and value of I is Mn upon minus U plus Mn upon R, right? Okay, so here I put the values. N1 value of I. Now N2 value of R. See here. So value of R is Mn upon R minus Mn upon V. Right. Here Mn is cancelled. Right. So here we multiplied N1 and here by N2. So we can write that N1 minus N1 by U plus N1 by R is equals to here N2 by R and minus N2 by V. Right. Here we have to prove equation like this. Minus N1 by U plus N2 by V is equals to N2 minus N1 by R. Right. So here we take minus N2 by V to left hand side and this R to right hand side. Right. So we get like this, minus N1 by U minus, if we take this to left hand side then we get plus. So plus N2 by V is equals to N2 by R, and this is plus. If we take right hand side then this will become minus. So minus N1 by R. Right. Now see, minus N1 by U plus N2 by V here is equals to N2 by R minus N1 by R. So we can take 1 by R is common. So we can write that like this, N2 minus N1 upon R by taking common. Right. So we can write like this. So the equation is minus N1 by U plus N2 by V is equals to N2 minus N1 upon R. So friends, this is very important equation for you, right? So the equation is minus N1 by U plus N2 by V is equals to N2 minus N1 upon R. So you have to remember this equation, right? Okay, thank you.